Alright, so the problem that I'm going to be solving is given a tangential acceleration of 1.6 meters per second squared and a car that is on a circle with a diameter of 250 meters, at what point in seconds would the acceleration centripetal equal the acceleration tangential? We're going to make a couple assumptions here. And one of those assumptions is that there is no friction. And the second assumption is that there is no air resistance. And given that there is no air resistance and no friction, we are going to describe our free body diagram in this way. All right, just like this. This is the mass times the acceleration tangential. This is the normal force, and this is our force due to gravity. And since we want the time when the acceleration tangential is equal to the acceleration centripetal, we're actually going to set them equal to each other. So our 1.6 meters per second squared is going to be equal to velocity squared over our radius, which is equal to the centripetal acceleration. Given this information, we're going to solve for the velocity and then use a kinematic equation to solve for time. So that's going to look like this. 1.6 meters a second squared times the radius, which is 250 divided in half, which is 125 meters, and then the square root of that, which is right here. That's going to give us the square root of 200, and then the square root of 200 is 14.14 meters a second, and this is going to equal our final velocity. Alright, so then we're going to use the kinematic equation, which is velocity final is equal to velocity initial plus acceleration times time. Here. We're still going to use acceleration's tangential as our acceleration in this equation. And then our velocity final is going to be 14.14 meters a second, set equal to 0, since we started at a velocity of 0, times 1.6 times our time. And then, to solve for time, we're just going to divide 14.14 by 1.6. Given that, we are going to end up with about 8.8 seconds being the time when our centripetal acceleration is equal to our tangential acceleration.